Problem 1. X and y have joint density function. Fxy of xy equals 1 plus xy over a absolute value of x less than 1 and the absolute value of y less than 1. 0 otherwise. Question 1. Find a so that the above defined is a valid joint density function. Absolute value of x less than 1, so x greater than -1 and less than 1. Absolute value of y less than 1, so y greater than -1 and less than 1. Integral -1 to 1, integral -1 to 1, fxy xy dx dy equals integral -1 to 1, integral -1 to 1, 1 plus xy over a dx dy equals 1 over a integral -1 to 1 x -1 to 1 plus y times x squared over 2 -1 to 1 dy equals 1 over a integral 1 -1 to 1 2 dy equals 1 over a 2y -1 to 1 equals 4 over a. It should be 1, so a equals 4. Question 2. Are x and y uncorrelated? E of xy equals integral -1 to 1, integral -1 to 1, xy times 1 plus xy over 4 dx dy equals 1 over 4, integral -1 to 1, integral -1 to 1, xy plus x squared y squared dx dy equals 1 over 4, integral -1 to 1, y times x squared over 2, -1 to 1, plus y squared times x cubed over 3, -1 to 1, dy. It's equals to 1 over 4, integral -1 to 1, 2 over 3 y squared dy equals 1 over 4 times 2y cubed over 9, -1 to 1. Equals 1 over 9. E of x equals integral -1 to 1, integral -1 to 1, x times 1 plus xy over 4 dx dy equals to 1 over 4, integral -1 to 1, x plus x squared y dx dy equals 1 over 4, integral -1 to 1, x squared over 2, -1 to 1, plus y times x cubed over 3, -1 to 1 dy equals 1 over 4, integral 1, -1 to 1, 2y over 3 dy equals 1 over 4 times 2y squared over 3, -1 to 1 equals 0. So ex times ey is 0, and e of xy not equal to ex times ey. So x and y are not uncorrelated. Question 3. Are x and y independent? Since x and y are not uncorrelated, so we can get x, y are not independent. Question 4. Find the joint density function of x squared and y squared. So let z equals x squared and w equals y squared. And we can get j equals x 2x 0 0 2y equals 4xy. And z equals x squared, w equals y squared have 4 roots. So j of I equals 4 times square root of the times square root of w. I equals 1, 2, 3, 4. Z greater than or equal to 0, less than or equal to 1, and w greater or equal to 0, less than or equal to 1. Fzw of Cw equals fxy square root of the square root of w over j1 plus fxy of negative square root of the square root of w over j2 plus fxy square root of the negative square root of w over j3 plus fxy of negative square root of the negative square root of w over j4. So it's equals to 1 over 4 square root of the square root of w times 1 over 4, 1 plus square root of the square root of w plus 1 minus square root of the square root of w plus 1 minus square root of the square root of w plus 1 plus square root of the square root of w equals 1 over 4 times square root of the square root of w. So fzw of the w equals 1 over 4 square root of the square root of w for z greater than or equal to 0, less than or equal to 1, and w greater than or equal to 0, less than or equal to 1. 0 otherwise. Question 5. Prove or disprove that x squared and y squared are independent. Fz of z equals 1 over 2 square root of z for z greater or equal to 0 and less than or equal to 1. 0 otherwise. And Fw of w equals 1 over 2 square root of w for w greater than or equal to 0, less than or equal to 1, and 0 otherwise. So we can get Fzw of Cw equals to Fz of z times Fw of w. And we can get x squared and y squared are independent.